Many refrigeration applications employ the direct cooling of a fluid instead of air. Fluid cooling evaporators are used for two primary reasons. First, it is most efficient to directly cool a beverage such as juice or wine compared to using air as a secondary coolant. Second, utilizing a fluid cooling evaporator to chill a secondary coolant such as water or glycol solution reduces the footprint of the refrigeration system. Instead of piping refrigerant throughout the plant, the secondary coolant provides the cooling, and the refrigeration system is limited to a central machinery room or area. This is particularly attractive when ammonia is the refrigerant because it limits the area where personnel might be exposed if a leak occurs. However, it is important to emphasize that any time a secondary coolant is used, the refrigeration system will be less efficient than when employing direct cooling. Many different types of fluid cooling evaporators are used in refrigeration systems. All fluid coolers, however, use a refrigerant to absorb heat from a fluid. The refrigerant and fluid are segregated so that they cannot mix, but the design is such that heat transfer is maximized. A shell and tube heat exchanger is a common type of fluid cooling evaporator. Shell and tube heat exchangers consist of a bundle of tubes located inside a cylindrical shell. The shell is typically an ASME pressure vessel. In most refrigeration evaporator applications, low-pressure liquid refrigerant is supplied to the shell and the fluid is pumped through the tubes. Heat is transferred from the fluid through the tube walls and into the refrigerant within the shell. As the refrigerant absorbs heat, it evaporates and is returned to the compressor. Sometimes refrigerant is supplied to the tubes and the fluid being cooled is in the shell. This combination is commonly employed in shell and tube oil coolers on screw compressors. Refrigerant is supplied by the thermosiphon receiver to the tubes and exchanges heat with the oil inside the shell. Shell and tube heat exchangers are widely used in the wine and other beverage industries. One advantage of shell and tube heat exchangers is that most tubes are large enough to accommodate high fluid flow rates and will not be affected by small solid materials such as pulp or grape skins that have not been filtered out. A downside of shell and tube heat exchangers is that they are typically very large, taking up valuable real estate at a refrigeration facility. A plate and frame heat exchanger is a second type of fluid cooling evaporator that is commonly used in refrigeration systems. These fluid coolers are popular because of their compact size, high efficiency, and ease of maintenance. Plate and frame heat exchangers consist of a series of thin corrugated metal plates, typically made of stainless steel. Each plate has a gasket that seals the plate edges to ensure the fluids do not mix. Small plate and frame heat exchangers are often seal welded to negate the need of gaskets altogether. A pair of plates is often called a cassette. The number of cassettes required will depend on the evaporator load. The cassettes are held together in a frame. The frame can be adjusted to add or remove plates if the refrigeration needs change. In a plate and frame heat exchanger, refrigerant enters the unit on one side of the plates and the fluid to be cooled on the other side. A big advantage of plate and frame heat exchangers is that the plate design and narrow channels provide tremendous surface area within a small footprint. Because of the narrow channels, however, plate and frame heat exchangers are not typically used for fluids that are thick or may contain small particulates. A plate and shell heat exchanger is a hybrid design that combines features of both the plate and frame heat exchangers and shell and tube heat exchangers, enhancing thermal efficiency and structural robustness. Plate and shell heat exchangers consist of a cylindrical outer shell similar to the shell and tube heat exchanger, but instead of tube bundles, they incorporate a pack of corrugated metal plates housed within the shell, like a plate and frame heat exchanger. In many refrigeration applications, the shell is fully welded. This reduces the risk of a leak, which is a benefit, but also prevents the heat exchanger from being modified. Plate and shell heat exchangers are often employed as oil coolers on screw compressors, but can also function as compact, highly efficient evaporators. A falling film chiller is a type of heat exchanger used for cooling fluids, typically in industrial applications such as food processing. Falling film chillers are designed to provide efficient heat transfer by allowing a thin film of liquid to flow over a cooled surface, maximizing contact between the liquid and the cooling medium. In a falling film chiller, the liquid to be cooled is distributed evenly over the plates, forming a thin film. Gravity causes this film to fall over the chilled plates, allowing efficient heat exchange as the refrigerant inside the plates absorbs heat from the liquid. The large surface area of the falling liquid film enhances the rate of heat transfer. The fluid collects at the bottom of the chiller and is pumped to the area where the chilled fluid is needed. A hydrocooler is a type of fluid cooling evaporator that is used primarily in the agricultural and food industries to rapidly reduce the temperature of freshly harvested produce. In a hydrocooler, freshly harvested produce is rapidly cooled by spraying cold water over an evaporator containing cold liquid refrigerant. The chilled water then enters a distribution pan so that the cold water is evenly distributed over the produce. As the produce passes through the cooling chamber, typically on a conveyor, the water absorbs heat from the surface of the produce, quickly reducing its temperature. The cold water is constantly recirculated and recooled to maintain the desired low temperature. Hydrocoolers are attractive because they are highly effective at reducing the temperature of produce quickly, which is vital for slowing down the respiration rate of fruits and vegetables and preventing spoilage. The downside of hydrocoolers is that they require large amounts of water that must be filtered and cleaned regularly. Furthermore, not all types of fruits and vegetables are ideal for hydrocooling. Produce that is sensitive to water exposure, such as berries or leafy greens prone to wilting, cannot be hydrocooled. An ice builder is a thermal energy storage system used primarily in cooling applications, where it produces and stores ice during off-peak hours, typically at night, and then melts the ice during peak demand periods to provide cooling. This process helps balance energy consumption, which can result in significant savings on an electric bill when time of use pricing is in effect. An ice builder consists of a large insulated tank containing pipe coils within. Water surrounds the pipe coils within the tank. During the ice formation phase, cold liquid refrigerant circulates through the pipe coils, absorbing heat from the water and causing it to change state into ice. The ice formation phase is typically performed at night when electricity is least expensive. Then during the day, when electricity is most expensive, the refrigeration to the ice builder will be shut off and the ice is allowed to melt as water is pumped through the tank and out to the plant to provide chilled water where needed. Ice builders are only attractive in situations where energy costs vary throughout the day. An ice maker is an evaporator designed specifically to make ice that will be consumed. There are various types of ice makers, all of which use cold liquid refrigerant to freeze water. A plate ice maker operates using the same principle as a falling film chiller. Water is sprayed or trickled over vertical or inclined plates containing cold liquid refrigerant. The temperature of the plates causes the water to freeze into a thin layer of ice. The process continues until the ice reaches the desired thickness. At that point, a defrost cycle is triggered, which loosens the ice sheet which falls off the plate. The ice sheet may then be broken into smaller pieces for use or storage. This cycle repeats continuously, producing a steady supply of ice. A tube ice maker is a specialized machine designed to produce cylindrical ice, commonly referred to as tube ice, which is hollow in the center. In a tube ice maker, water flows over the outer surface of vertically oriented ice-making tubes. The refrigerant circulating through the evaporator cools the tubes, freezing the water from the inside out, forming a hollow cylinder. The thickness of the ice can be controlled by adjusting the time the water remains in contact with the cooling tubes. Once the ice reaches the desired thickness, a hot gas or defrost cycle is initiated, warming the tubes and loosening the ice cylinders, which then fall out and are cut into smaller, uniform pieces. A flake ice maker is a machine designed to produce soft, thin, and irregularly shaped pieces of ice, commonly referred to as flake ice. In a flake ice maker, water is circulated or sprayed onto the outer surface of the evaporator drum. As the refrigerant cools the drum, the water freezes into a thin layer of ice on the surface. A scraper blade rotating inside the drum continuously scrapes the ice as it forms, breaking it into small, thin flakes. The ice flakes then fall into a collection bin, or they are conveyed to a storage area for use. Flake ice makers are widely used in fish, beef, and poultry cooling. A jacketed tank is a type of tank commonly used in industries such as food and beverage processing and is designed to control the temperature of its contents. These tanks feature a jacket, which is an outer layer or compartment around the tank that allows cold liquid refrigerant to circulate, thus regulating the internal temperature of the tank's contents without direct contact. The inner tank is the main compartment where the liquid is stored. Since these tanks are commonly used in the food industry, they are typically made of food-grade stainless steel. Many tanks have an agitator or mixer to ensure uniform distribution of heat and to prevent the contents from settling or sticking to the walls. This is particularly useful in applications where maintaining a homogeneous mixture is crucial. The outer jacket is often dimpled, allowing the refrigerant to pass through the pockets formed by the dimples, which increase the heat transfer efficiency. Some jacketed tanks are fully insulated so that the outer jacket is not visible to the naked eye. Many jacketed tanks are directly cooled by refrigerant, but others use a secondary coolant, typically a glycol solution. A scrape surface heat exchanger is a specialized type of heat exchanger designed to handle viscous, sticky, or other materials that are prone to fouling or crystallization on the heat exchanger surface. The unique feature of this type of evaporator is the use of rotating blades or scrapers that continuously remove product buildup from the heat transfer surface, ensuring efficient heat exchange. In a scrape surface heat exchanger, the product flows through the cylindrical chamber where it comes into contact with the inner walls of the cylinder, which contain cold liquid refrigerant. The rotating scraper blades continuously remove any material that tends to stick or build up on the surface, exposing the product to fresh, clean heat transfer surfaces. As the product moves through the cylinder, the refrigerant cools the product through the wall cylinder. This setup ensures efficient and consistent heat transfer while minimizing the risk of fouling, freezing, or overprocessing. Scrape surface heat exchangers are used to cool thick products such as oil, chocolate, sauces, jams, custards, and ice cream. Direct contact freezing is less commonly employed than air cooling or fluid cooling, but can be highly efficient. The plate type freezer is the most common type of direct contact evaporator. A plate type freezer is a specialized evaporator used to rapidly freeze products by placing them in direct contact with cold metal plates, which are chilled by refrigerant. In a plate type freezer, products are placed directly between or onto cold metal plates. The refrigerant circulating inside the plates absorbs heat from the product through direct contact, rapidly lowering their temperature and freezing them. Because the freezing occurs via direct thermal conduction, the process is highly efficient, ensuring fast and uniform freezing. The plates can be hydraulically or pneumatically pressed to improve contact with a product, enhancing heat transfer. Plate-type freezing evaporators are used in the meat industry for freezing fish fillets, beef patties, but are also employed to freeze packaged foods, such as ready-to-eat meals and frozen juice concentrates.